Hey, good afternoon, algebra. In this lecture, this is 3.5 in your notes, we're going to talk about scatter plots, and this is one of the things that you're definitely going to see in biology, physical science. So what I want you to be able to do at the end of this lesson is not only create scatter plots, I want you to also to be able to interpret scatter plots and then use trend lines to make predictions between actual data points and where something might go in the future. There's a lot of vocabulary again, and we're going to work our way through it. Again, math is about vocabulary, so we want to understand what these things mean. So the first thing to note is a scatter plot is a way to display a relationship. So technically, a scatter plot is a graph with the points plotted to show a possible relationship between two sets of data. Sometimes we think of it as independent and dependent, X and Y. A scatter plot is an effective way to display points of data. You've heard the expression that a picture is worth 1,000 words. Well, a picture of data often just stands out at you to give you a much better sense of meaning. Let me show you what I mean. So the table shows the number of points scored by a high school football team in the first 4 games of the season. Graph a scatter plot using the given data. Well, one of the key things when you do a scatter plot is it has to be to scale, which means you can't just arbitrarily pick units. You need to make sure that each unit is the same distance apart for what you're doing. What I mean by that is the following. My axis here, my x-axis, is going to be the game. And I've got 4 games, so I'm going to space them equally apart. And I can do this in an easy way. This is going to be game 4. Then I'm going to take this is 0, this is 4. Halfway in the middle right here is game 2. And then I split these in half again for 3 and 1. That's an easy way to make a roughly good scatter plot. Graph paper is a much better way, but I think you get the point. Now, the score is going to be dependent on the game. That's going to be my y. So this is score. And it's so important to label it. Now, the highest score that I have is 46. I don't have any scores that are negative. I shouldn't. I could have a score 0. So let's go from 0 all the way up to 50. And in fact, you have to start at 0, 0. If you want to jump ahead, we'll do that when we get to statistics or whatnot. You'll use something called a break. But for now, this point always has to be 0, 0, and you're going to start from there, unless it doesn't make sense to do that. So I'm going to go up here. I'm going to call that 50, and I'm going to split this length in half. So right here is about 25. I'm going to split this in half again. Halfway between, it's about 37. Halfway between 25 and 0 is going to be, we call that 13. And so now I have a scale. I have a way to graph this. And again, in an ideal world, I have to start at 0, 0. I can make a break here if I need to jump up to numbers that make sense. But each of these here is about 13 units apart, 12 or 13 units apart. See, this is 12, this is 12, this is 13, that's 13 numbers between each. Each one of these is one whole game. That makes for a really good scale. Now I'm ready to plot it. So game 1, I had 6 points, right here. Game 2, I had 21 points, about there. Game 3, 46 points. Oh man, we were getting good. Game 4, 34 points. I should be, have to move my picture out of the way. Game 4, 34 points. Right about there. That is how you make a scatter plot. Correlation describes a relationship between 2 data sets. So a graph may show that the correlation, a graph may show correlation between data. Correlation is a way to help you see a pattern, find a trend, and make a prediction. In general, there's 3 types of correlation. Let me get my picture out of the way. You have a positive correlation, whereas the value of x increases, so does the value of y. You have a negative correlation, or downward slope. As you increase x, the value of y goes down. See, as I go this way, it goes down. No correlation means the data is spread all over the place. The ski runners are going by, so hang in there. Meaning there's no real pattern in the data. Okay, again, if you need to pause the video and get anything, go for it. So let's take a look at this. It says, describe a correlation illustrated below. Well, as the years go on, the number of participants snowboarding increases. So I would say that's a positive correlation. Pretty good? All right. Identify the correlation you would expect to see between the different pairs of data sets. So what I want you to do is, as you go along this, I want you to think about it before I give you the answer. So you can pause the video. So the first one, the average temperature in a city and the number of speeding tickets given in that city. What do you think? Well, if you said there was no correlation, you're right. Why would the average temperature, whether it's warm or cold, affect the number of speeding tickets? Second problem, the number of people in an audience and the number of tickets sold. Well, if you said, well, yeah, they're definitely related, that's right. I mean, some people might buy a ticket and not show up, but I bet they're pretty positively correlated. The number of tickets sold means there's probably more people showing up. Fewer tickets, fewer people are going to be in the audience. All right, try this one. I'll move my picture out of the way. A runner's time and the distance to the finish line, which means before you've even started running, you've got all the way to go to the finish line. And after an hour, you should be closer to the finish line. And after 2 hours, you better be really close to the finish line. So in this one, if you said a negative correlation, you'd be right. Last example here, the temperature in Houston and the number of cars sold in Boston. Well, does Houston and Boston have anything in common? Shouldn't, so this would be another example of no correlation. Now, let's play another game. This game says choose the scatter plot that best represents the relationship between the number of minutes since a pie has been taken out of the oven and the temperature of the pie. Go ahead, try it. All right, well, if you selected graph A, you were spot on because the temperature coming out of the oven might be 250, 325 degrees, but then it cools and cools and cools, and actually it cools only to the point of the temperature of the room. It doesn't go below room temperature. Graphs B and C have something completely different. We've got negative time. What? That doesn't make any sense. Graph C, but the temperature is going up? I don't think so. The last thing we need to talk about are trend lines. And when you graph a function with a scatter plot, sometimes you can see a relationship easier with a trend line. It helps to show that correlation. And what a trend line looks like is the following. So based on the trend line, predict how many wrapping paper rolls need to be sold to raise $500. Well, in this example here, what I want to do is actually put in a line. And I like to use dashed lines. So I'm going to go right about here. And what I'm trying to do with this line is to say, hey, wait a minute. That line does a pretty good job estimating where these red dots fall. The more rolls I sell, the more money is raised. So it's definitely a positive correlation. So based on the trend line, predict how many wrapping paper rolls need to be sold to raise $500. Well, I don't have a, right about here is 500, right? So I would zoom over here and say, oh, I'm exactly in between 50 and 100, so that would be about 75. Does that sound pretty reasonable? I think that's enough. That's a 9-minute video. Thank you for paying attention. I'm sure we're going to hit this hard on class on Wednesday. And so if you've got time, work on your Khan Academy.